This video is about conditional statements. You can find more about this in your textbook in section 2.1. We all think of geometry as being about shapes, and while it does involve shapes, at its core, geometry is all about logic. And whether you're a math person or not, any kind of critical thinking is going to require logic. Logic has some fancy vocabulary, which you may or may not yet know, and here it begins. If-then statements, conditional statements, and conditionals are all the same thing. These are statements that say something like, if it rains after school, then I will give you a ride home. You can see the if and the then in this statement, and the other parts of the statement are called the hypothesis and the conclusion. It rains after school is, in this statement, the hypothesis. And I will give you a ride home, in this statement, is the conclusion. Because that's what follows if it's true that it's raining after school. So if-then statements have the general form if P, then Q, where P is the hypothesis and Q is the conclusion. Sometimes conditional statements are worded in such a way that it's not completely clear to us what the hypothesis and what the conclusion are. For example, I'll buy you a slushie if you tie my shoes. Well, I see an if here. I don't see any then in this statement, but there is a then implied. So the hypothesis is the thing that we're wondering, the thing that we're starting out with is the hypothesis. So in this case, we're starting out with you tying my shoes. The conclusion is the thing that happens if the hypothesis is true. So in this case, the conclusion is, I'll buy you a slushie. Another example, x squared equals 25 implies that x is less than 10. The word implies is another way of wording an if-then statement. And in math, we have a symbol for the word implies. So we basically say that the hypothesis, P, implies the conclusion, Q. Identify the hypothesis and conclusion in these statements. The converse of a statement is formed by switching around the hypothesis and the conclusion. For example, the converse of if it rains after school, then I will give you a ride home is if I'm giving you a ride home, then it must be raining. So, is the converse of a true statement always true? I'm going to give you a minute to think about that. Look carefully at these two sentences and think about whether this being true implies that this is true. The answer is no. The converse of a true if-then statement is not always true. As we've just seen, an if-then statement might be false. For example, the converse of the statement we just looked at was itself an if-then statement, but it was false. Another example of a false if-then statement is, if Ted lives south of Canada, then he lives in Texas. This is an if-then statement. It has a hypothesis and a conclusion, but that doesn't make it a true if-then statement. Some if-then statements are false. So to disprove a conditional statement, it only takes one valid counterexample. To disprove the statement above, you might say, well, Ted could live in Arkansas. If he lived in Arkansas, then he would still live south of Canada, but it wouldn't be true that he lives in Texas. So the key to a good counterexample is that it makes the hypothesis true, but the conclusion false. Provide a counterexample to show that each of these statements is false. Here's one more new vocabulary word for you. A biconditional statement is kind of like an if-then statement on steroids in that it's a much more powerful kind of statement than a plain old if-then statement. Because a biconditional statement has the characteristic that its converse is also true. An example of this, an animal is a dog if and only if it is a Canis lupus familiaris. The converse of that, an animal is a Canis lupus familiaris if and only if it is a dog. Both the statement and its converse are true, and we can switch it around without any risk of making it untrue. Rewrite this pair of conditional statements as a biconditional statement. Another wording for our first biconditional statement is this: a Canis lupus familiaris is a dog. That doesn't look like an if-then statement at all, but in fact, it's just a rewording of the if-then statement, or rather, the biconditional statement that we just looked at. It's a definition, and we could look at it as a definition of Canis lupus familiaris, or we could look at it as a definition of dog. But either way we look at it, what it's saying is that these two things are identical. All the definitions that we have in math are biconditional statements. They may be biconditional statements in disguise, but they're all saying that two things are identical or interchangeable. The mathematical symbol for a biconditional statement is this, and we can say P and Q are logically equivalent. P implies Q and Q implies P, or P is true if and only if Q is true. For the following statements, decide: is the statement true or false? Is the converse true or false? And is this a biconditional statement? For further practice, see your textbook, page 35, numbers 7 to 29 odd.